The enigma of Pythagoras, mathematician and mystic. What connects the logic of numbers to the mysteries of a secret society? This question lies at the heart of Pythagoras' intriguing life. He was more than just a mathematician. He was a philosopher, a spiritual leader, and an enigma. His ideas transcended the realm of pure mathematics, shaping the way we understand the universe and our place within it. A legacy etched in stone, the enduring impact of Pythagoras. Pythagoras' influence echoes through millennia. His name is synonymous with one of the most fundamental theorems in geometry, but his impact extends far beyond the classroom. From architecture and engineering to music and art, his ideas continue to shape our world. Even today we grapple with the philosophical implications of his discoveries. A thirst for knowledge, the formative years of a visionary. Born on the Greek island of Samos in the 6th century BC, Pythagoras displayed a thirst for knowledge from a young age. He traveled extensively, seeking wisdom from the most learned scholars of his time. Egypt, Babylonia, and Persia became his classrooms. He immersed himself in mathematics, astronomy, and music, laying the foundation for his groundbreaking discoveries. Of the universe. Pythagoras' most famous contribution is, of course, the Pythagorean theorem. This theorem, which states that in a right-angled triangle the square of the hypotenuse is equal to the sum of the squares of the other two sides, has become a fundamental principle in geometry. It is not just a mathematical equation but a cornerstone of architectural design, engineering, and even art. The simplicity and elegance of this theorem have fascinated scholars for centuries, making it a timeless piece of mathematical wisdom. This elegant equation reveals the relationship between the sides of a right-angled triangle. It has practical applications in various fields, from constructing buildings to navigating the seas. The Pythagorean theorem is not just a theoretical concept, it has real-world implications that have been utilized by civilizations throughout history. Its discovery marked a significant milestone in the development of mathematics, providing a tool that has been indispensable in both ancient and modern times. But, his mathematical explorations went far beyond this single theorem. Pythagoras was a pioneer in the study of numbers and their properties. He believed that numbers were the essence of all things and that understanding them could unlock the secrets of the universe. His work laid the foundation for many branches of mathematics, including number theory and geometry. Pythagoras' approach to mathematics was holistic, seeing it as a way to understand the world in a deeper, more meaningful way. He explored the properties of numbers, believing them to be the building blocks of reality. Pythagoras and his followers, known as the Pythagoreans, delved into the mystical and philosophical aspects of numbers. They studied numerical relationships and patterns, seeking to find harmony and order in the universe. This belief in the power of numbers influenced not only mathematics but also music, astronomy, and philosophy. Pythagoras's insights into the nature of numbers have had a lasting impact on various fields of study. He established the concept of perfect numbers, explored geometric sequences, and introduced the idea of mathematical harmony. Perfect numbers, which are equal to the sum of their proper divisors, fascinated Pythagoras and his followers. They saw these numbers as symbols of perfection and completeness. Geometric sequences, on the other hand, revealed the beauty and order inherent in mathematical patterns. Pythagoras's work in these areas demonstrated his deep appreciation for the aesthetic and philosophical dimensions of mathematics, and laid the groundwork for the study of irrational numbers. These numbers, which cannot be expressed as a simple fraction, challenged the Pythagoreans' belief in the rationality and order of the universe. However, their discovery opened up new avenues of mathematical inquiry and led to a deeper understanding of the complexities of numbers. Pythagoras's contributions to mathematics were profound and far-reaching, influencing countless generations of mathematicians and scientists. His legacy continues to inspire and challenge us to explore the mysteries of the mathematical world. The discovery of irrational numbers, like the square root of 2, was a groundbreaking moment in the history of mathematics. This revelation didn't just add a new type of number to the mathematical lexicon, it fundamentally altered the way ancient mathematicians understood the world around them. The Pythagorean Brotherhood, a secretive group of mathematicians and philosophers, was thrown into turmoil. They had built their entire worldview on the belief that numbers, specifically whole numbers, were the essence of all things. The idea that there could be numbers that were not whole, that could not be expressed as a simple fraction, was deeply unsettling to them. This discovery challenged their fundamental belief in the absolute order of the universe, dictated by whole numbers. The Pythagoreans believed that the cosmos was an orderly, harmonious place, and that this order could be understood through mathematics. The existence of irrational numbers seemed to suggest that the universe was more complex and less predictable than they had thought. Legend has it that Hippasus, a member of the Brotherhood, was punished, perhaps even killed, for revealing the existence of these unsettling numbers. According to the story, Hippasus was the first to prove the irrationality of the square root of 2, and his discovery was met with outrage and fear. The Pythagoreans were so disturbed by this revelation that they allegedly threw Hippasus overboard during a sea voyage, silencing him forever. Whether true or not, the story highlights the profound impact of this mathematical crisis. It serves as a reminder of how deeply held beliefs can be challenged by new discoveries, and how those challenges can lead to fear and resistance. The discovery of irrational numbers was a pivotal moment in the history of mathematics, one that forced mathematicians to rethink their understanding of the world and paved the way for future advancements in the field. Despite the internal conflicts and the passage of time, Pythagoras's legacy endured. Plato and Aristotle, giants of Greek philosophy, were influenced by his ideas. The Romans applied his geometric principles to their architecture and engineering projects. During the Renaissance, artists like Leonardo da Vinci incorporated the golden ratio, a concept linked to Pythagoras, into their masterpieces. Even today, Pythagoras's theorems are more than just abstract concepts found in textbooks. They are woven into the fabric of our daily lives. Architects and engineers use the Pythagorean theorem to design buildings, bridges, and roads. GPS technology relies on it to calculate distances. Music, with its harmonious ratios and intervals, still bears the imprint of Pythagoras's fascination with the mathematical principles of sound. But the story of ancient Greek mathematics doesn't end with Pythagoras. Another fascinating figure awaits our exploration: Zeno of Elea, a philosopher whose paradoxes challenge the very nature of motion and infinity. Prepare to delve into a world where a tortoise might just outrun the swiftest runner, and where an arrow, frozen in time, never quite reaches its target.